For the inscribed angles, so what that is, it's an angle that has a vertex on the circle. So the vertex is actually on the circle itself. And then the sides of the angle are chords of the circle. So if we look at the diagram that's given off to the side, it says in circle G, minor arc DF is the intercepted arc for the inscribed angle DEF. So this angle here, DEF, that would be an inscribed angle. Vertex E is actually on the circle. And then when we talk about the intercepted arc, that's the arc that is kind of in that opening of the angle, if you want to think of it that way. The end points of the arc are where the chords there intersect the circle. So then ED would be a chord, EF is a chord, and those are the sides of the angle. Then we get into the inscribed angle theorem, and this is helping us determine if we have an inscribed angle, how that angle measure compares with the arc measure. So if an angle is inscribed in a circle, the measure of the angle is equal to 1/2 the measure of its intercepted arc. And that actually is stated right underneath that diagram. It says the measure of angle DEF is equal to 1/2 the measure of arc DF. So another way to phrase that equation, the arc measure is actually twice as big as the angle measure. So the measure of arc DF would be equal to 2 times the measure of the angle. That's a different way to set up that equation. So the angle is 1/2 of the arc is twice as big as the angle. And that is the theorem that is being used in the first set of examples there. So in 1, 2, and 3, where it says find each measure, so here you just need to pay attention to whether you have the measure of the angle or the arc and which one you're trying to find so that you know if you're dividing it in half or multiplying it by 2. So if we are looking for the measure of arc AC, and so the measure of the arc, this would be like that second equation I wrote up here. It's twice as big as the angle or twice the measure of the angle. So I'm just going to write this here. So if you're looking at your notes, you know where you're getting your answer from. The measure of arc AC is equal to 2 times the angle measure, which is 36 degrees. And then 2 times 36 is 72. So the measure of arc AC is 72 degrees. And then we're just doing the reverse of that. In number 2, we're looking for the measure of angle N, and we have its intercepted arc is 62. So the measure of angle N is going to be 1/2 of the arc measure, so 1/2 of 62, and that would be 31 degrees. So then in number 3, if we're looking for arc QSR, how would we find that based on what we're given? Are we going to be multiplying the 113 by 2 or dividing it in half? Multiplying it by 2. So it'd be 226 degrees. All right, and I realize when you look at these things in the notes or even on the assignment, and they're all kind of grouped, like similar problems grouped together. We just talked about this theorem, so obviously we know we're using it for these 3. So it's a little bit easier, I'd say, within the lesson, within the assignment, to recognize that that's what you have to use because they're all grouped that way. So this is something that you have to be able to recognize if you were given any diagrams, knowing what an inscribed angle is, vertex on the circle, and knowing that relationship to the arc measure. Then we have, if you have more than one inscribed angle, so it says if 2 inscribed angles intercept the same arc, or they could intercept congruent arcs, then you know the angles themselves are congruent. So if two different inscribed angles intercept the same arc, or they intercept arcs that you know are congruent, you know the angles then are congruent. So to look at this, so if we look at examples, actually 4 and 5 go with this first circle here. So 4 is having us find the measure of angle U. And so I can see that U is an inscribed angle because the vertex is on the circle. And the arc that it intercepts is arc WT. And then I notice angle V over here also is an inscribed angle and has the same intercepted arc. They both intercept arc WT. So therefore, angle U and angle V must be congruent to each other. So if angle V is 30, angle U must also be 30. So that's how to use that statement that's above. And then example 5, finding the measure of angle T, that's similar. So if we look at angle T, that is an inscribed angle, and that intercepts arc UV. And then I notice another angle for arc UV is angle W. So angle T and W must be congruent to each other. And that allows us to find the measure of angle T because then I can set those expressions equal to one another. So I know that 3x plus 4 must equal 2x plus 9. If I solve that for x, subtract 2x from each side. So x plus 4 equals 9. And then subtract 4. X is 5. I'm not looking for x, though. I'm looking for the measure of angle T. So what is the measure of angle T? All right, so why don't you go ahead and answer both 6 and 7. So for this circle, find the measure of angle A and the measure of angle C for example 6. Quick check, let me know. I just want to give you a chance to work through it, so let me know if you are stuck on something. Okay. Check your answers. I didn't. I was just making sure that you had a chance to work through it. But double check the actual final answers you got. So A and D should be congruent to each other, and you would get y is equal to 10. If you substitute that in, you can find A is 58 degrees. And then B and C are congruent to each other. You should get x is equal to 8. And if you substitute that in, angle C is equal to 45 degrees. Okay, any questions with inscribed angles? All right, so then getting into inscribed polygons, and we're just looking at triangles and quadrilaterals specifically. Need your attention up here though, please. So for triangles, this one says that the inscribed angle of a triangle or an inscribed angle of a triangle intercepts a diameter or semicircle if and only if the angle is a right angle. So looking at this picture, I can see that angle G is intercepting a semicircle, since FH is a diameter, so FJH, that arc would be a semicircle. And so since it's intercepting a semicircle, that makes G a 90-degree angle. So that will only happen if that angle is a 90-degree angle, meaning you have a right triangle. And then vice versa. If you knew that was a right angle, that would tell you that FH is a diameter, or that FJH, that arc, is a semicircle. So that's a key theorem we're going to use with triangles. And then with quadrilaterals, this one says that if a quadrilateral is inscribed in a circle, and remember, for both of these, inscribed means that all of the vertices are actually on the circle. But if it's inscribed in a circle, its opposite angles are supplementary. And what does supplementary mean? Add up to 180. So that means in this picture here, L and N, so the opposite angles would add to 180. So the measure of angle L plus the measure of angle N would equal 180, as well as K and M, the measure of angle K plus the measure of angle M is equal to 180. It doesn't say anything about opposite angles being, or any angles being congruent. It's not, I can't say, that L and K would be the same, M and N would be the same, but I know that opposite angles, those pairs of angles, should be supplementary, should add to 180. Oh, that's kind of cut off there a little bit. There we go. So those two theorems are used in the next sets of examples. So we have the triangles for 1 through 4, and then we have the quadrilaterals for 5 through 8. So I actually want to go through a triangle one with you and then a quadrilateral one with you. So we'll go through these two, and then I'll have you work through these two, and we'll look at the writing question that's there. So for 1 and 2, with that triangle in that circle, again, since I noticed that WX is a diameter, that makes this inscribed angle Y a right angle. So therefore, if I'm looking for X, how would I find X? Okay. Yep, I could combine everything and set it equal to 180, or I could combine just these two and set it equal to 90, since I already know this is 90. Either way, it doesn't matter. Combine all three, set it equal to 180, or just combine the two angles that are not the right angle and set them equal to 90. I'm going to do that. So I know x plus 12 should equal 90. So 2x plus 12 should equal 90. And then I would be subtracting 12. And that would give me 2x is equal to 78. So if I divide by 2, then x is 39. And that's what number 1 is asking, is just what is x? So x is 39. And then 2 is looking for the measure of angle W. So then I'm substituting 39 in, and 39 plus 12 is 51. So measure of angle W is 51, or 51 degrees. So again, I know these examples are right here. We just talked about the theorem, but as we move past this lesson, it's about you still recognizing when this happens that you have a right triangle. So that's something that we'll have to come back and revisit and practice. So then for 5, I'm going to skip down to 5 and 6 here. We have a quadrilateral, QRSP, or PQRS. And we're looking for the measures of angles R and S. And here we know from that second theorem up above that the opposite angles are supplementary, should add to 180. So I know if I'm finding angle R, and R is 3x, I know 3x and the 75, so 3x plus 75 should equal 180. And that allows me to solve for x. So then I can subtract 75. So I'm going to go up here. So 3x equals 105. And then if I divide by 3, is that 35 for x? And then if I know x is 35, now I can actually find r and s, just substitute the 35 in it. So I know 3 times 35 is going to be the 105 for angle r. And then if I multiply 35 by 2 to find angle s, I get 70. Okay, any questions on any of those examples? Otherwise, go ahead and answer the 3 and 4 and 7 and 8 here. And then I am going to discuss with you that writing question, but if you're just waiting, you can take a look at that. We're going to compare and contrast inscribed versus central angles. So revisiting what a central angle is. But at least work through these examples on the right side of that sheet there. Okay, check what you have. Excuse me. So for 3, did you not get those answers? Check what you have, 3 and 4. X should be 16, and then angle T is 58. And then 7 and 8, for 7, to find W, you need to find X. Make sure you have the right X value, it should be 54. And then when you substitute that into angle W, you get 72. And then for angle X, you have to find the variable Y, which should be 31, and then substitute that into angle X to get 86. So careful when you find the variable that you look to see, is that your answer, or do you have to plug it back in to get something different? Any questions on those? Otherwise, we're going to talk about the writing question. Okay, and if you already took a look at this and kind of wrote some things down, make sure you have the correct information written down. So this says to compare and contrast inscribed angles and then central angles of a circle. And then it says if they intercept the same arc, how are they related? So we talked about, if I were just to sketch this off to the side, say here's the center. So an inscribed angle, that's what we just worked with. So it has a vertex on the circle and then has endpoint, or has chords as sides, and then it intercepts an arc. So this would be like an inscribed angle. What is a central angle? Yes, so it's an angle that has a vertex at the center of the circle. So I'm going to draw it because then it says if they intercept the same arc. So if I were to draw a central angle that intercepts the same arc, it would look like this, because the vertex would actually be at the center. So I have this angle, and then I have this angle. Okay, so that is a difference. I guess a similarity is they are both angles in a circle. So you could say, because it does say compare and contrast. So I'm going to say both angles are in a circle, but inscribed angles have a vertex on the circle and central angles have a vertex at the center of the circle. All right, so that is, they're both in a circle. They have a different vertex. And you don't have to write word for word what I have if you just wanted to jot down notes to make sure you know the difference. But then it says if they intercept the same arc, how are they related? How are the measures of the angles related? Anyone know the answer to that? So, or Isaac? Which one will be? Yeah, the central angle would be twice the amount. So say, as an example, say this arc measure. All right, I need it quiet, please. Okay, this arc measure, say this arc, I'm just going to make up a number, say it's 80. Okay, that's not accurate according to my picture, but say it's 80. A central angle, the measure of a central angle is equal to the arc measure. So that central angle is still 80. That's only if the vertex is at the center. If it's an inscribed angle, it is half of that. So then it's 40. So the central angle is twice as big as the inscribed angle. So I'll say if they intercept, and this is only if they intercept the same arc. So if they intercept the same arc, the central angle is twice as large as the inscribed angle. Okay, again, or it's your notes if you just jotted that down, but making sure, just as in most chapters in geometry with circles, vocabulary is extremely important, and then knowing the relationships between all of the angles we talk about is very important, because those are just things you have to remember. So any questions on this? Otherwise, I'll pass out the assignment.